Okay, so we're talking about why on earth are we doing this? Why are we going to this convoluted way of talking to a variable by having to go through methods first? So I went ahead and did the second one here for the width. So let's go back to this guy. And so there's absolutely nothing you can do to prevent me from saying len2 is equal to minus 40. Right? There's nothing you can do to prevent me from doing that. But if I said our set length minus 40, when I run this, it's going to say, sorry, value must be above 0. So this didn't generate an error at all. So there's basically two different types of input validation. One type of input validation is when you're asking the user to provide information, right? So that's what I call the primary input validation. So primary input validation is when the user of this application is entering the width. We're not even doing that here. We skipped all that. Secondary input validation is assuming that the programmer is passing valid things to your class. Now, you might think, hey man, look, you're the programmer, you ought to know better. But in a commercial world where you're trying to sell a product, that's just not good enough. You're going to have to account for bad programmers. So primary input validation, I think everyone agrees that's a valid thing to do, is to make sure that when you ask people for something, you get the acceptable range. We've been doing this all along. But now we're talking about secondary input validation to make sure that some idiot doesn't accidentally type in set length equals minus 40 kind of a thing. Okay, so that is one of the reasons why you should do that, okay? And let's talk about one of the other techniques. So to do this, I have to finish off this class. So I need to have a fifth method down here, and the book calls it get area. I don't like that, okay? I'm going to call mine double calc area. All right. So calc, hey, you know how this thing works. I'm returning a double, so I'm just going to go ahead. You got this pattern, right? You know what I'm going to do, right? Of course you do. I'm going to say double answer, and then down here I'm going to say return answer, right? And then I'm going to go back in the middle and fix it. Okay, you've seen me do this before. All right. Yeah. Okay, so why did I call it calc? Because I don't like the word get. Get to me sounds like a getter and a setter. Now there's some really cool terms for this thing. They call them accessors and mutators. Now, again, if you were taking a history of computer science course, maybe some of these archaic terms may be useful, but I'm never going to ask you that. Those names are silly. Everyone that I know calls them getters and sitters, okay? So you get something or you set something, all right? Kind of makes sense. In addition to getter and sitter, when you talk about them as a pair, you talk about the get length and the set length as a pair, a lot of programmers call these properties. So we have two properties. We have a length property and a set and a width property. In other words, don't call them by the setter name and their getter name. Just collectively, when you're using them in pairs, just call them properties. Okay, so I may say, for example, in something, well, it's going to have these properties. And so that means, behind the scenes, that means, two methods for each one of those things. If I said it has to have 4 properties, that means it's going to have 4 setters and 4 getters. Okay, good. All right. So because set and get means something specific to me, I don't use things like use those in other contexts. There's a whole lot of other words you can use. You can say, fetch, retrieve, and all sorts of other stuff. But calc in this thing makes sense. Okay, so here we go. So I'm going to say answer is equal to PFV length times PFV width. Okay, so let's go back to our guy and let's do that. So I guess I'm going to have to go ahead and take this out. So now I've set the length successfully. And then I'm going to say, let's just do system.out.println and say area is, and then I'm just going to do it this way. I'm going to say r.calc area. Cool. All right. So let's run this, see what it does. And the area is 0. 0? What did I do wrong? Well, now this is the other part. You know, we talked about the primary input validation and secondary input validation. The third one has a little catchy name. I call it sanity checking. Look, these are just names that I use, okay? The real name is called state validation. What this means is the system in the proper state to provide you the correct answer? And the answer is no, because all I did was set the length. I never set the width. So there's no way this thing could provide you the correct answer. So let's put in an if statement that basically says if PFV length is equal to 0 or PFV width, dang, I can't type, is equal to 0, then we want to spit out an error message. Something that says, hey man, we're not ready yet. I don't know. I'm not spending much time on these error messages. I probably should have something a little bit more sophisticated. But anyway, something along the lines of both the width and length must be set. Okay. So what I'm doing here is I'm trying to figure out how to do input validation, primary, secondary, and sanity checking. Sanity checking is really secondary input validation, except there's no real input involved, right? So it's kind of hard to call it input validation when we don't actually have one. Okay, so that's why I call it sanity checking. All right, let's run this. Then it says both the width and the length must be set. Boom. Okay, cool. Because this thing returns a double, all paths must return a double. So I could have it return something here or whatever, right? So you could just say something like, maybe you have like a magic number in mind when there's an error message. So you would do like a return, like -1 or something. I don't know. Something to let people know that an error has occurred. That might be kind of handy. Because otherwise you might look at that and go, wait a minute, cool, makes sense. All right, so one more time. Why on earth are we doing this? Well, input validation. Primary input validation is typically done someplace else. Primary input validation is typically done here, okay? And I'm not demoing any of that. We've done that in Chapter 4. We've done that in Chapter 5. I think we've got that. No need for me to repeat. Secondary input validation is when a programmer does something stupid, or when the programmer is asking for something when it's not ready. So secondary input validation is this part here where I'm checking to see if you're giving me a legitimate value, and I'm checking to see if we're even ready to answer your question, because maybe we're not ready. Okay? So it kind of sort of makes sense. Okay. So, one more time. Why are we doing this? Well, the first one is it provides me an opportunity for secondary input validation, because -40 is not a valid length or a width. 2, it provides me an opportunity for the other type of secondary, which I call it sanity checking, to see if the area is actually, are you capable of calculating the area? Because if you're not, then I need to let you know. Okay. So now you got it. Now, let's talk back about the example in the book. The example in the book didn't do any of this at all. And so if you're looking at the book, and the book alone, when I first was doing this, I went, there's no advantage of me going through and typing in, set length and get length and all that. Why on earth am I doing this when there's no advantage whatsoever? I have no idea why they didn't show you what the advantages were up front. I guess they just assumed you were good little soldiers and you were going to be doing what you're told and not having to think about why. And I don't like that. I want you to know why. And in fact, I'm going to spend a heck of a lot of time not on the mechanics of Java the Hutt. I'm going to be spending a heck of a lot more time on the philosophical questions of why we are doing something. Okay, so my teaching philosophy does not match the book at all. Okay, so on page 338, they kind of sort of start talking about it. Not that they give a decent example, but they start talking about it. And they talk about, blocking direct access to field variables and then forcing the users to use methods instead. Now, right off the bat, is this more efficient, this technique? This technique of doing setters and getters, is that more efficient than if we were to just talk directly to the field variables? What do you think? No, of course not. I mean, look at all the stuff that has to happen. Instead of just talking to Lynn, I have to do a get length and I have to do a set length, right? There's a lot of code in here that has to happen. All this, there's a penalty to pay for all of this secondary input validation. Yeah, there is. So no, it is not more efficient. That would be dumb. So we're not doing it because we want to. we're doing it because we want the thing to work flawlessly. We want it so somebody could beat it and abuse it and it'll still work. That's what you expect when you're buying a component, right? I'm buying a piece of software and I want to use it in my application. I expect to beat the heck out of it and have it still work. I don't want to break it. If you can easily break a piece of store-bought software, then that software probably isn't worth that much to you, right? Okay. Okay. So I'm going to go down to this guy right here. So we've got a lot of these things. I'm not going to sort alphabetically. I don't like that. I want to sort it by the way we wrote it in the application. So that I'm going to click that little button off to the side. So let's look at this in some detail because, again, I'm going to be asking you to do some stuff. So the diamond is the rectangle. The diamond. Yeah, the diamond is the class, okay? And then the padlock means it's private. And then the blue means it's just a plain old field variable. So we have a private field variable, and then a public one, which we're not actually using for anything. And then we're going to have a getter that returns a double, a getter that returns a double, a setter that takes a double, a setter that takes a double, and then a calc that returns a double. Okay, is this all making sense? Now, this is how this thing works, and it works fairly well. If I was to go in and make something static, okay, there's no need for me to make something static. I'm only doing this to demonstrate how this thing changes. So I'm just going to take this guy right here and say static, okay? I'm not going to leave it that way. But see how I put a little bar in there? Okay, so this is the thing showing the fields. This is the thing that shows all the static, show the private guys, and then the normal stuff, okay? So I'm not going to do that. In fact, I'm going to take this one out completely. That was just a demo to show you what can and can't be doing. All right. Kind of sort of makes sense? Yes, you're going to have to know these little symbols, and we'll talk about them again in just a minute. Okay, so using their thing, the UML diagram, they use pluses and minuses. So a minus on the length means it's private, and then a plus down here means it's public. Since I'm not actually going to be doing that, we're not actually going to be generating UML diagrams. That's just, in case you come across this in some other class, pluses and minuses is the way that UML diagrams show whether they're private or public. Okay, we're coming up on the 15-minute mark. Let's do what we always do.